Hello everyone. This is a talk about Multilib, if anyone has actually ever heard of that before. Certainly if you're an embedded toolchain developer, you've probably heard of it before. But it's essentially a way, well, while Clang and LLVM natural cross compilers, then what you're going to do about your precompiled binaries. So I'm thinking about here about your C library, your C++ library, at least the binary portions of it, compiler RT. So if you want to support more than one target platform with a single toolchain, you have to supply multiple different instances of libraries. And you probably most likely encountered this on an x86 Linux system when you've targeted old 386, and that actually uses something like, uses something called Multilib. And it's essentially all it's doing is switching directories. So effectively you have a mapping from command line options to directories, and that's what Multilib will set that up for you. So here's just a very simple example. The actual things here are not important. This is the next slide will just show you the diffs. So yeah, the important thing is it contains things like what's the location of your dynamic linker, what's the library paths, where's your sort of C runtime, and then with -M32 you'll notice that those paths have changed. So that just enables you to have multiple libraries in the same system. Okay, so far so simple. Okay, so here's how Multilib is currently implemented. You'll notice some things there. I'm using here some code from the Android Multilibs just to sort of introduce this by example. You have a Multilib, which is a class that represents one particular instance of a library. And then there's a Multilib set, which is kind of a combinations of ones that the compiler will select between. And these are all built by, well, they can be built by these Multilib builder and Multilib set builder, which makes this sort of a nice interface to use. Without going into too much things, all of those ARM v7a and thumb is essentially, that's representing things of what happens if I've got v7a without thumb, thumb without v7a. It's basically all four possible combinations, and then it selects a particular directory for those. Yeah, so this has been in Clang for ages. And so if you wanted to have Multilib in your particular toolchain, you had to write something like that. Okay, so configuration-based Multilib is essentially for what happens if you have an embedded toolchain that can have like hundreds of these things. And worse than that, it's not just your embedded toolchain, it's several other companies' embedded toolchains, several different targets. So it's essentially impractical for every possible embedded toolchain to put all of that upstream. So the idea of configuration-based Multilib is how can we defer the creation of those classes to runtime rather than that. So currently we've got, I think it's still in alpha experimentation because we're sort of experimenting with the format. Main reason for me to do this talk is to sort of make people aware of this and to hopefully get people to try it out and tell us what works, what hasn't worked, so we can perhaps enhance the format. But essentially what we're doing is reading from a YAML file, which I'll show you an example of, that's going to define what things are going on, what multilibs are there, any particular mapping files, any ways of sort of canonicalizing some of the options, of which I'll go through probably more on the next slide. So here is a very simple one that comes direct from the design. You have your example directory there, so you've got two multilibs, v6m, v7m, and what it's looking for is a particular target. You'll notice there that target is a bit more complex than one you would normally give. That's because the command line options will be canonicalized into that target, so you can select it with just one thing rather than multiple things that all overlap. Anyone who's tried to use march and mcpu and how they all interact, it can get quite complicated. The last bit at the bottom is a mapping, and it's essentially a regular expression that says if you've got, say, thumb v8, then just treat it as thumb v7. So that's basically trying to map, basically account for future things and to stop you having to have huge amounts of things of just one thing. Okay, so some experience with what we've done so far. So the biggest restriction we found some ways is where you want to select a multilib based on something that isn't a command line option. So say for example, you've got threads or no threads. Well, there's no C Clang driver option for selecting that. So ideally we would want something where we can describe something like a multilib equals string, where we can define those strings in the configuration file just to sort of help things along there. We also found some problems with the C++ library paths, where we ended up with having to, rather than having a layered sort of instance where you could stack multiple directories, we ended up with a problem where this. Anyway, I won't go into too much detail for that one, but it was otherwise I'll run out of time. Okay, so conclusion there. So you can. Okay. I better stop then. Yeah. Okay. Yeah. So sorry. Okay. So this is just basically a conclusion saying that we've got more work to do to handle some more complex cases. It's an active use. We're seeking feedback. Please report back over discourse or anything like that. Okay.
Thank you.